Brad Williams, Frugal Finance, welcome. And this is going to be a brief introduction to the next 33 lessons within this course. Summary of continuous compounding and discrete interest factors. Hate to say this, but we're going to be delving heavily into math. A lot of formulas, so don't be intimidated. I'm going to walk you through just it's old school and it's formula driven, but this is the foundation for everything moving forward. There's 22 courses. You'll be surprised how much we depend on present value and future values in finance to solve problems. With that being said, summary of continuous compounding and discrete interest factors. What this is present value and future values and compounding. Generally, when we're doing finance, we use monthly compounding. But in the next 22 sessions, we're going to move towards continuous compounding. Sometimes it can pose problems. Not in the calculation, but in the logic. These tables help you figure out how much money grows or shrinks over time, either continuously or in steps. Single payment, present value. If you want to know how much a single payment is worth now, given a certain interest rate and time, you can use the factor, continuous, or discrete formulas. Down here, 1. Here is the layout. There's 2 different formats. We're going to have what I call the traditional approach, and this is E is going to represent continuous, or EXP will be continuous. This symbol, this is going to be for the engineers, this is how they're taught. And then for finance people, this is how I was taught. We have factor discrete, and this is the traditional style. And then we have symbol discrete. Here is number 1. You're going to look at 1 single payment factor and then single payment present value. Why is this important? Because, as I mentioned, there's 33 additional lessons attached to this course, and I'm going to show you examples of every one of these things. I don't expect you to memorize this information, but what I want you to do is remember to fall back on this. So there will be examples where I might say refer back to the very first lesson. So here again, this is number 1, single payment. Number 2, single payment future value. Future value. So look right here, and this is the format for single payment future value. Notice the difference. We're going to use a negative n into the power. Here, we're just going to use normal n. Number 3, uniform series compound amount. This is for figuring out how much a series of payments will be worth in the future. Keep in mind, future. So if we read here, this is a uniform series compound, and we're going to go 1 plus I of n. And I'm not going to break these down per se. It just gets too complicated. And yeah, I know. You're saying, how am I going to differentiate? Well, keep in mind, looking to the future. Number 4, sinking fund. If you want to save up for a future expense by making regular payments, this helps you figure out how much you need to put away each time. So what we need to do here in number 4, uniform series sinking fund, and most likely we're going to look at some type of present value. How much do we need to put in today to pay off that future amount? 5, uniform series present value. If you want to know the current value of a series of future payments, you can use this formula. Notice number 5, uniform series present value. We're going to have this 1 plus I of n. Here we have this right here. In number 2, we have that starting formula. Minus 1, then we're going to have I, 1 plus I of n, which is, again, the same as in number 2. So the question is, why are we doing this? Well, that's what we're working towards, but you can see we're using this future value formula in order to compute this present value information. I know you're asking yourself, if you want to know the current value of a series of future payments, well, we're using future value right here. We're using 2 and combining them. Number 6, capital recovery factor. This is about figuring out how much you need to receive regularly to recover a certain amount of money over time. Here we have number 6. So you're going to see I, 1 plus I of n, minus 1. So we have I, it's going to be time 1 plus I of n divided by I plus n. Again, you can see up here, what are we doing? We have I plus n. So there's a future value factor in here. And divided by 1 plus I of n minus 1. It's like we just turn this around. I know, I'm not going to try to explain each one of these. Over time, you'll see the logic. Then we're going to have this number 7, the gradient series. What? If you have a series of payments that increase or decrease over time, this helps you figure out their current value. Sort of sounds like an annuity, doesn't it? So here, number 7, gradient, would be 1 minus 1 plus n. Keep in mind this notation is kind of screwy, just because it's so friggin' hard to work with Excel. So we have this layout, 1 plus I of n. Then we have number 8, gradient series, uniform. So number 7 said present value. Number 8 most likely will be a future value. And this is for finding the value of a series of payments that grow or shrink at a constant rate over time because of the types of calculations you're going to do. Are we growing? Is there a constant flow of revenue? Number 9, geometric series, present value. This helps you find the present value of a series of payments that change at a constant rate over time. This is how similar all of these formulas are. This is basic algebra. If you need to solve for something, you can just pick a variable and you can try to solve for it. Somebody's already done it. Why do you want to take the time to do that? Because you may be really smart, or you just may be curious, and then you just start plugging and chugging. There's nothing that tough about it other than the fact that it takes time. There are also a lot of tools online that will solve this for you, and it's a time saver. It's called SimLabs. And once we get into swaps, I show an example where I used this online tool, and it's beautiful. All right. The only cheating factor is you're relying on third party. And if somebody asks you about that particular solution, yeah, you may be stumped. And the person was going to go, did you solve this? Or did you have a third party? And lastly, geometric series, future value factor. Similarly, this helps you find the future value of a series of payments that change at a constant rate over time. I want to make sure my ugly mug is not covering this stuff up. Over here, number 10, geometric series. This is the discrete, and then this is the continuous. Then over here are some other examples. There's a summary of continuous compounding interest rate factors for continuous flow. This is a brief introduction. I didn't want to intimidate you by all of this stuff, but this is what we're going to be working with. Brad Williams, Frugal Finance. Lots more to come.